All right. So now we're going to go over operation of the Hitachi S4500 SEM. There's a lot to this system, so I'm just going to start by going over all of the indicators on the diagnostic panels, and then we'll go from there, getting images and so forth. So on the far left here, we have the display power. This toggle turns this display on and off. Next, we have the objective heater. The aperture needs to be heated to prevent thermal stress. So this should be on as long as the vacuum is properly on. We also have the evac power, and then these three interlocks that determine whether or not this will be tripped. So when this is on, the vacuum system is turned on and connected to the system. When the air pressure, water, or DP/TMP are not satisfied, it will trip the system and it will turn off the evac power. Next, we have our ion pumps. We have 3 ion pumps that can be all reset using these buttons. And then you can check the pressure in each of the ion pumps using this gauge here. And you can change the scaling of the gauges using this top dial here. Next, we have the vacuum for the main chambers. So we have 2 main chambers here, plus our gun chamber. We have the sample chamber, SC. This is where you place your sample to be imaged. You have the sample exchange chamber, SEC. This is a load lock, basically, so you can put your sample in here and then transfer it into the main chamber once the load lock is at a proper vacuum. The proper vacuum is determined by these indicators. So you basically have air, low, and high. Of course, when you're operating it, it has to always be in high. The low vacuum indicator indicates that it's low, but it's not at atmosphere. And then, of course, air indicates that it's at atmosphere. You also have these three this gauge here for these 3 Pirani and penning gauges. So you have 2 gauges for the sample chamber, a Pirani gauge and a penning gauge, and 1 gauge for the sample exchange chamber, which is just a Pirani gauge. By switching between them, you can get the different vacuum levels of each one of the gauges. Finally, on this section, we have the sample exchange valve. Right now, it's closed. This is an indicator that determines whether this mechanical valve here is open or closed. So as we open it, you can see that it now says that it's open. And then close it, vice versa. Now we have over here on this next section, the evac and venting system. So down here, you can switch between the sample chamber and the sample exchange chamber. And you can either evacuate it or vent it using these 2 buttons. Additionally, you have an airlock. While you're not using the system, the airlock should always be closed to ensure the safety of and vacuum of the main chamber. While you're using it, this will have to be open. So that is an interlock that prevents the gun from turning on when the airlock is closed. Finally, you have a stage lock. This can prevent any mechanical vibrations that may exist in the system and can get you a better image if that's happening. Next, we can go over to the panels for the vacuum system. Over here, we have a STP control unit for the turbo pump. It has a gauge right here indicating the rotation speed. As you can see, the needle here is now in the green, indicating that it's in normal rotation speed. We have a main power, and then start and stop to the motor. Then we have indicators of the state. So right now, it's running in a normal operation state. If it's off, say, for example, for some reason the pump gets turned off or it gets tripped, you'll start it, go to acceleration, and then to normal operation. It also has all these indications to determine, basically to diagnose issues with the system. On the bottom here, this is the control for our ion pumps. This control is completely dedicated to ensuring that the gun chamber is at vacuum. So what you have here is your 3 ion pump switches. This turns those ion pumps on. This also does the gun chamber baking, which is a common maintenance for these systems. In general, you won't have to worry about this, and we'll go over that in the troubleshooting section. that's it for most of the panels, at least for now. Next, we have, of course, the main image taking panel. So on here, we have your high voltage off button, your high voltage on button, and then your flash. Here you have your acceleration voltage, the extraction voltage, and the emission current. And then you have your magnification. Here's your magnification control, your stigmation control, your coarse and fine focus. And then on the keyboard, you have all of these functions to do different stuff with the column and with the microscope. So what we're going to do is we're going to use a gold on carbon test sample for SEM. This is, in general, the, I guess you'd call it the gold standard for testing the SEM. So the first thing we do to load the sample, we're going to press the air button while the SEC switch is toggled. You can hear the pneumatics actuate. Now it's opening this up to the vent gas, which is nitrogen from the back. So now we can open the chamber, push in the exchange rod. Now we attach, that might be too tall. Yeah, that's going to be too tall. All right. All right, so now we have our sample such that it is lower than the spar. That means it will fit in our chamber properly. So now that we have that, we can attach it to our exchange rod here. We gently close this, and we press the evac button. Now, so that we can see what's going on in there, we're going to turn on the chamber scope display. So we have two on switches, the one here on the controller, and then we have the monitor. So the coax cable for this is a little bit frayed. It sometimes has errors with it. If you usually tap it, the contacts will come right back. And then, of course, you can always just replace the coax. So, as you can see, our sample exchange chamber has reached high vacuum. We just want to make sure the sample chamber is also at high vacuum before we start the gun. But now we are able to perform the sample exchange. So we gently slide it in. It locks into place on our sample stage. We unscrew the exchange rod, pull it back out, and then we close our valve. Now, when you're taking images, you want to have your sample as close to the detector as you can. So up here is the detector, and if you kind of imagine a triangle being made with these two angles, if your sample can be within that area, that's where you'll get the best image from your sample. So to do that, we can control the Z height right here. So we just unscrew it up. You see it raises the sample. And we just want to put it in that area, the virtual lens. All right, that's good. Now the next thing is to open the sample chamber airlock. When you do that, you can see that this button here turns on. This indicator determines whether or not you can turn on the gun. So the first time that you, so this is the airlock right here. The switch, it should be off when you're not using it, and then you open it when you're about to start using the gun. And when you open it, the indicator on the high voltage buttons will turn on. So you see this green light is on now, indicating that you can actually turn on the gun. If you're the first one to use the system in the day, you want to flash the tip. You do that by pressing the flash button. You'll see the LED here will start blinking. Press the on button, and you'll see that the emission current will spike. That's a current flash. And when it does that, that basically runs a current without a high voltage through the emitter tip, and that kind of is supposed to eject any contaminants on the tip. So now we can turn it on. Now that we flashed it, you press the on button. You can hear the aperture open. We're using a acceleration voltage of 3 kilovolts. There is literature published on the best acceleration voltage to get good images. As a relation to what kind of cooling and what effect it might have on your sample. We also have our extraction voltage here. You can see it's at 4.5. Ideally, we should be able to get it to 4.3 if we're regularly flashing it. So since it's already at 4.5 before we start, I'm going to flash it one more time. So in general, you shouldn't flash it too often, but we have a set extraction voltage where we want to keep it at 4.3. And if you start the day and you see that it's past that extraction voltage, it's fine to flash it again. Just as you use it, this extraction voltage is also going to be going up. In that case, don't flash it again. You want to limit the amount of times you flash the tip. So I'm going to flash it one more time. See the emission current rises. Now we're going to turn it back on. A lower extraction voltage will indicate a better image quality. It basically indicates that your emission is proceeding well if you have a lower extraction voltage. You see now we're able to get to a 4.4. That's already lower to the 4.5 that was. Now we have emission current around 10 to 12 microamps. So I'm not going to flash it again. I don't want to go too much with it. So we'll just go right into taking images. At the very start, of course, it's going to be a little bit blurry. So you're going to start with your coarse focus. Until you can get a better image. Then you go to your fine focus. More. Now we can have somewhat of a clear image of our gold nanospheres. We're going to zoom in some more. Zoom in a little bit more. And get as clear of an image as we can. Zoom back out. Now we're going to do some chamber conditioning things. So we're going to, column conditioning. We're going to adjust the column. This is especially important the first use of the day. So the first step is the beam alignment. Zoom in until your beam is visible on the screen. Now you want this circle to be in the center of your screen. So use the X and Y stigmation alignment to bring that beam to the center of your screen. There we go. Now it's at the center. Press enter. Now we're going to go on to the aperture alignment. So this is going to have to be at a higher magnification. And what this does is it wobbles the focus. And if the aperture is aligned, the features should still stay in place, but they'll kind of go in and out of focus. If it's poorly aligned, you'll see it kind of moves back and forth. So you want to reduce that lateral and vertical motion as much as possible, although it's still going to wobble. That's do a little bit better. That's pretty all right, so we'll just stop there. Next, we're going to do a stigmation alignment. This does the same thing, but with the stigmators. As you can see, it's barely moving. Usually these stigmators don't get very unaligned. But this one, as opposed to the aperture alignment, you can actually get it to stop completely. Whereas with the aperture alignment, it's going to keep wobbling to some extent. So that's in the X direction. Now we're going to align the stigmators in the Y direction. There we go. And then now we can press exit. So I'm going to move to a different spot here, just to look at some other stuff. And we're going to try and get a better image out of this. So we're going to zoom in first, and we're going to start with a coarse focus. So now that our beam is properly aligned, you can see the individual gold nanospheres sitting on the carbon. Let's get a good a focus as we can. And now when you see that we kind of wobble our focus, you can see the image sort of stretch and pull in different directions. The reason this happens is because of stigmation. Stigmation occurs when the beam, the electron beam, is a circle, or an oval, rather than a circle like it's supposed to be. To correct that, we have these two stigmation alignment knobs, and basically the way that you're going to approach this is you're kind of just going to go back and forth. So you're going to use your stigmation knobs to get the best image that you can. Once you do that, you're going to go back to your find focus. Do find focus again. And then go back and forth. So now we're going to do the stigmation again. And then back to the find focus again. And you can repeat this as many times as you like until you're satisfied with the image that you get. So now I can see pretty clearly the nanospheres of gold, whereas before we did all of these column adjustments and stigmation, all we could see was the overall film of gold. And clearly now you can see the actual individual nanospheres. The next thing that we can do, I'm going to zoom out, and we're going to change the brightness and contrast. So in this image, the contrast seems kind of high, so I'm going to turn the contrast down and turn the brightness up. When you do this, your image will be more of a grayscale, which is especially useful when you're trying to look at 3D structures. If you have a very high contrast, you'll just be able to see, you know, kind of the top of the structure and the bottom of the structure, and you won't see any of the actual topography of the sample. So the more grayscale your image is, you're going to more easily be able to see the topography. It's less important for this sample because all you have here is nanospheres of gold. But just in general, when you're talking about nanostructures, you kind of want to have a lower contrast once you get to your actual image. The next step here is to take this image that we have on here and transfer it onto a computer. So for that, we have this Quartz PCI slow scan software. It's basically a USB connection between this scanner and this computer. So to get an image, we're going to press acquire, and we're going to do a continuous. So it says here it will only do microscope speeds of 1, 2, 3, and 4. So right now we are on a scan speed of fast TV. The slower the scan speed on our image, the higher resolution we're going to have our image. Essentially what's happening is the electron beam is scanning over the image more slowly so it can take in more details. So we're going to put this on 3. And as we do that, you can see we have a much higher resolution image coming out. And in turn, you know, the resolution on the computer is going to be higher than the resolution on these monitors. So if we're satisfied with our image, we press stop. Now we have our image from here on the computer. I think that's about it. Yeah. So that's how you get an image from your SEM.